Hello, this is the TI84 guy, and I have a couple of things I need to say. Earlier this summer I wrote a program called QUADFAC that basically factored, FOILed, or completed the square for any quadratic. And then I realized that I had written a couple of different programs. Let me kind of go and show you what I'm... The first program is what I wrote this summer called QUADFAC, and it factors, FOILs, completes the square for any quadratic. And then I had another program called QUADRATIC that actually found the roots of any quadratic. It would also find the sum of the roots or the product of the roots. And then I had another program called QUADRegression that if you gave it 3 points on a parabola, it would tell you what the equation is for the quadratic. And I had a realization or epiphany that why do I have 3 different programs when I can basically combine all of these functions into one program? So that's what I've done. And that's what this video is about. I've written a program and I call it QUADRATIC since it just deals with quadratics. And it combines the QUADFAC, QUADRATIC, and QUADRegression, and it puts it into one program. And this is what the program's going to do. It will factor, it'll FOIL, it'll complete the square, it finds roots, it finds the sum of roots or products of roots, and it also finds the equation, the quadratic equation given 3 points. And I call it QUADRATIC. Simple enough? Alright, so now I'm going to demo it. That's what this video is going to be about. And I think this is probably the best program that I've written. And it pretty much handles anything that you have to do with a quadratic. So let's just jump in. Alright, so here I'm going to show you that it can FOIL first. And then I'm going to show you that it can factor. And then I'm going to show you that it can complete the square. And then we're going to look at some SAT questions, okay? So let's go here. I call it QUADRATIC. Okay, it's called QUADRATIC, and in this case you have 4 options. You can have an input that's in the standard form, you can have an input that's in the vertex form, you can have an input that's in the factored form, you can have, if you're given 3 points, you can input that and it'll find out the quadratic equation for you. Okay, so in this case we're going to look at 2x times a negative 2x minus 3. So let's go. So we're going to use option 3 here. It's going to be factored coming in, and the first term, the a term, is 1. The p term is going to be 2. The l term is going to be 0 since there's no term for that. And then we're going to put in a negative 2 for the O term, and then we're going to put in a negative 3 for the F term. And then we're just going to press enter, and we want it in the standard form. So we're going to choose option 3, and it's going to give you the standard form. So it gives you the input that you originally inputted, and then it's going to give you the output, whatever it is that you want. We want it in the standard form, so this is the standard form. So now let's go to the next one. The next one has, it's factored. You see that it's factorable, and then it goes to the standard form. I'm going to go the other way just to show you that it can also go from standard. So we're going to choose option 1, standard. So it's going to be 12, then it's going to be 14, and then it's going to be 2, and then we're going to say, can you factor it? And it factors it. So it's 2x, and look, it factors it completely. This one here actually has 2n plus 2. You can actually pull a 2 out of here. You could factor a 2 out, right? So you'd be left with 1n plus 1. So this, my program actually factors it completely. This is not factored completely. So you can give it the standard form and it'll factor it. So hopefully that's clear. Now I'm going to show you another one. Show you that it can handle this one as well. Okay, so right now I'm going to look at this one. I'm going to put it in the standard form, and then I'm going to factor it. So press enter. So we're going to enter the standard form. So it's going to be 16, a negative 8, and then 1. And then we're going to say, is this factorable? So we're going to choose option 1. And it tells you that it is factored and it's a perfect square. So you can see it's 4x minus 1 raised to the second power. So you can, so hopefully you see that it can FOIL and it can factor. So now I want to show you that it can also complete the square. So we're going to look at this term. So we're trying to find the value of c that completes the square for this. So in this case, I'm going to press enter. And the input is going to be standard. So we're going to have the leading coefficient, or the A term, is 1. The B term is going to be a negative 34. The C term, which is what we're trying to find, we're going to make a 0. And then we're going to say if we complete the square, or alternatively, if we put it in the vertex form, it says that to complete the square, you're going to have to add 289, which is what you see here. Okay, so this is in the vertex form, so it means that the vertex of this would be at 17 and a minus 289. Got it? Let's do another one. Now I'm going to take, let's do this one. We're going to go in standard form. And it's going to be, let's see, it's going to, A is going to be 1, B is going to be a negative 38, C is 0, and then we're going to put it in the vertex form, or complete the square, and we can see that completing the square, we have 361. So now you can see that it completes the square, it factors, and let me go the other way. I want to show you that as well. So let me write this again. So in the vertex form, we're going to have x minus 19 squared minus 361. So now press enter. We're going to enter it from the vertex form. So we're going to choose option 2. The A term is 1. The H term is going to be 19. The C term is going to be a negative 361. And we are going to put it in the standard form. So we're going to choose option 3. And there you have it. X squared minus 38x. And there's no constant because we said it was 0. So it can go either way. It can go from standard to vertex, or from vertex to standard. Okay, now let's jump into why I think this is a good program to have for the SAT. The SAT now is testing a lot of your ability to go from different forms of the quadratic function, right? So they may give it to you in the standard form, and they say, and then the question asks you to put it in the vertex form, or they may give it to you the vertex form and ask you to put it in the factored form. This program will be invaluable in doing that. So let's look at this first question. It says the equation is x squared minus 2x minus 15, and they want it in the vertex form. So all we're going to do is we're going to choose option 1, and we're going to put in the coefficients 1, a negative 2, a negative 15, and then we're going to press 2, and it'll put it in the vertex form. So the answer for this one would be D. Now let me show you one other thing really quickly. Let's say that they didn't give us this equation, but we can see that from this graph that the roots are a negative 3, 0, 5, 0, and then we also see that it crosses the y-axis at a negative 15, 0, or 0, 15. So let's choose option 4. Go down to option 4. So we know 3 points. One of the points is a negative 3, 0. Another point is 5, 0. And then our last point is 0, negative 15. So we're going to put in 0, a negative 15. And then we're going to say, what is the vertex form? So we choose option 2. And as you can see, it gives you the standard equation for the 3 points, and it also puts it in the vertex form. Now, one last thing. Whenever you choose option 4 with 3 points, It's also going to give you, let me clear this other stuff out. This is from something else. It's also going to give you the equation. It puts the equation into y1, so if you want to graph it or look at the table, you can do that as well. So that's another feature that I added. Okay, so now that's the first question. Here's another one, also from a SAT practice exam. They've given it to you in factored form, and they want it in the vertex form because they want the minimum value. So you would choose option 3, and the first term, the A term, would be 1. The P term would be 1. The C term, or the L term would be 6. The O term is going to be 1. And the F term is going to be a negative 4. And then we want it in the vertex form, so we're going to choose option 2, and it will put it in the vertex form. So the answer for this one would be choice D. Let's go. All right, so now here's another problem that I wanted to demonstrate. Make sure it's in here and we're all focused. All right, so this was they give it to you, and they give you this quadratic in the standard form, and they want you to put it in the factored form. So they're asking for the x-intercept. So that's the same thing as the factored form. So we're going to choose option 1 for standard. We're going to enter the coefficients: 1 for A, a -6 for B, and 8 for C. And then we're going to choose option 1 because we want it in the factored form, and it's factored. X minus 2, x minus 4, x minus 2, x minus 4. Got it. Let's see. What else do I want to show? All right, here's the other feature. This is the part that I've added. So now we're given the quadratic in the standard form, and they want us to find the roots. They don't want us to factor it. They want us to find the actual roots. So we can do that pretty easily too. So we press enter. We're going to choose 1, and we're going to put in 4 for A, a -8 for B, and a -12 for C. And then we're going to choose option 4 for the roots. We're going to choose option 4, press enter, and the roots are 3 and -1. So we're choosing option B here. Okay, so it also finds the roots. Now, here's another one. Now, let me, there are some limits to what the program can do, and I want to demo those too. The program basically can't handle any fractions or decimals for coefficients. So in the standard form. So let me show you that. So if you try to enter this, and this problem actually wants you to find the roots because they want to find out how much time it takes before the ball hits the ground. So basically we're finding roots here. So but if we put in the original equation, a -4.9 and then 25 for the B term and then 0 for C, it tells you I can only handle integers, right? So it's saying this is the A term doesn't work. So how would you fix that? You can just multiply all of the terms by 10, and then you've gotten rid of the decimal. So let me show you that. So I'm going to take standard, I'm going to go -4.9, and then I'm going to multiply it times 10, and then you've got to multiply every term by 10 in the equation. So then we have 25, we can multiply that times 10, times 10, and then the C term, which is 0, I'm just going to show you we can multiply that times 10, but of course 10 times 0 is 0. And now we want to find the roots. So either we can choose option 4 or we can factor it if you wanted to factor it. But let's find the roots. The roots are 0 and 250, 49. So 250 divided by 49 is about 5.1. So the closest answer would be choice D. So remember, if you're looking for the roots, and you have a decimal, if you have decimal or fractions in the standard form, you can multiply by whatever number it takes to clear the decimal or the fractions, and the roots don't change. It doesn't matter that I multiplied it by 10. This root is the root for this quadratic as well. So if you multiply a quadratic by an integer, the roots don't change. The maximum would change, or the minimum would change, but the roots don't change. Okay, and I hope that's clear. Okay, what else do I want to do? Here's the other one that I wanted to show. I wanted to make this about 15 minutes, but I'm going a little over, but hopefully this won't be a big issue. All right, so let's look at this one. Oops, let's quit. I went to the wrong thing. I want program, and then I want quadratic. Okay, so now this question says, what is the sum of all the values of m that satisfy this equation? All right, so they're basically asking for the sum of the roots. So what we're going to do is we're going to put in the standard form. It's going to be 2, a negative 16, and then a plus 8, and we want option 5. Press enter, and that means the sum of the roots is going to be 8. The product of the roots is going to be 4. They're asking for the sum, so it would be choice D. So basically that's everything that the program can do, and I wanted you to see how this would benefit you on the SAT program or SAT test. Now, even though this problem came from the non-calculator section, the reason that I showed it is because this problem could easily show up in the calculator section, right? So the fact that it's in this section is almost kind of arbitrary. I just wanted to show you the functionality of the program. All right, so I'm going to show a couple more programs that I think just to show you the usefulness of it. So I'm going to look at this one here. Let's see, get it in the camera here. Okay, so in this problem, we're given which of the following equations represents the parabola shown in the xy plane above. So we've got this parabola. They give us the vertex of 3 and negative 8. Although it actually didn't say this was the vertex, we're kind of assuming that. It would have been nice if the problem actually said the vertex is at 3 and negative 8. But when you look at the choices, if you understand the vertex form of a parabola, you should know that it can't be B or D, because those two would mean that the x-coordinate is going to be a negative 3, and we can see obviously that it's a positive 3. But so we've got choices A and C. So I'm just going to use the program here, and I'm going to choose option 4 for because I know 3 points, and the 3 points that I know are this one, 1, 0, and the vertex, which is at 3, a negative 8, and then the other one's at 5, 0, so 5, 0. And then I want it in the vertex form, so I choose option 2, and there we have it, 2x minus 3 minus 8, so that would be choice C. Let's see, what else did I want to do? I'm going to do one more. Let's see. I'll show this one at another point. Let's look at this one here. We have, they give us a quadratic function in the standard form. And the question says, the monthly profit of a mattress company can be modeled by the equation above, where P is the profit in dollars, and M is the number of mattresses sold. What is the minimum number of mattresses the company must sell in a given month so that it does not lose money during that month? Okay, so basically, you can either factor this and find the roots, or you can just find the roots directly. So let's just do that. So let's go here. We're going to choose standard. The A term is 1. The B term is a negative 100. And the C term is a negative 120,000. And then we're going to press enter, and then we want the roots. So we're going to choose option 4. And it tells us that the roots are 400 and a negative 300. We can't have a negative 300 mattresses, so the only choice is 400. Okay, so let me go back. So I had a program called QuadFact that I demoed earlier this summer. And then I decided, instead of having 3 separate programs that did 3 different things, I would combine them all into one program. So the program that I've written now is called Quadratic. It factors quadratics, it FOILs binomials to get quadratics. It completes the square and puts it in vertex form. It finds the roots of a quadratic. It finds the sum of the roots and the products of roots. And it also, if you're given 3 points, it can find the standard form of the quadratic. So anything pretty much that you would want to do with a quadratic, this program can handle it. So if you're taking Algebra 1 or Algebra 2, or if you're preparing for the ACT, SAT, Math Level 1, Math Level 2, PSAT, this program will help. It'll help. So if you would like a copy of this program, there's just 3 things you need to do. Send me your email, subscribe to the channel, and if you would like the video, I'd appreciate that as well. And I'll try to get you the program as quickly as I can. Okay, so I hope you see the value in the program, and if you'd like a copy, just send me your email. Thanks.